All right, there's a few things that I want you to be aware of for the supermoon tomorrow because it has a number of different ways that we can prove that the popular flat Earth model is a red herring and that we're in a simulation. And I'm not even going to bother with whether or not we're on a ball anymore. Anybody that's following my channel right now knows that we're not on a ball. So Austin is at 30.26 degrees north latitude. And here's timeanddate.com for Austin. Here's today right now. So the moonrise is supposed to be at 5:19 p.m. at 77 degrees, and it's supposed to set at 281 degrees at 5:41 a.m. tomorrow morning. Now, if you look at these angles, this right here presents a problem, and I'm going to put this in a SketchUp and I'm going to show you what the issue is. So here we are in SketchUp with the Gleason map underneath us, and this is what's presented in the popular flat Earth model as far as the sun and moon doing circles around an AE map. Okay, circles around like this. Now in the Gleason, here's our equator, and it's broken up into 15-degree segments. So this right here is 15 degrees north, here's 30 degrees north. I'm in Austin, which is 30 degrees north, so that works out real nice. So I'm zooming in here, and this is the way I represent things. This circle right here being, a radius of what we can see out to the horizon from our vantage point. So here we've got this line right here is set at 77 degrees. This one right here extends right up to what would be the North Pole. So that's our true north and south going through here. This is 77 degrees. This one right here is set at 281 degrees. This right here is set at 70 degrees. And I took that from timeanddate.com. It says that the moon doesn't pass the meridian today. I'm going to show you that it does. And so I'm just sort of extrapolating that it's 70 degrees based on yesterday's meridian passing and tomorrow's meridian passing. So this is 70 degrees here. And this right here is the path of the moon. Now when I film it, the moon comes up here. It's drifting to the south as it's ascending, and then it gets to its peak right here. And then now like tonight, it'll come around just a little bit past, true west to 281 degrees. This right here is the path of the moon. Now what I'm going to do is I'm going to show you another location at 30 degrees north. So I was looking for another location in the United States at 30 degrees north, and Middleburg, Florida is a place that I came across. This is pretty close to what Austin is. Now, Middleburg has information in timeanddate.com. So we come down here, and on the 13th, the moon rises 77 degrees east, sets 281 degrees west. Now, they do have a meridian passing of 72.1 degrees. I just want to show you. Here's Austin. All right, there's Austin. And tonight it says the moon does not pass the meridian on this day. Now, if you read that paragraph right there, this has to do with the globular model, and it's just rubbish. I can show you that it does pass the meridian this day. So let's go back here. We've got basically the same sunrise angles, moonrise angle, and moonset angle. And now let's go put that into SketchUp. Now, because the angles are the same, what I've done is I've just copied what I have right here, pasted it in place, and what I'm going to do is I'm going to grab the rotate tool and take what I have here and just move it over to Middleburg, Florida, right about there. So now, We've got the exact same thing we had before in Austin, and it's in Middleburg. We've got the 77-degree moon rise coming up to, this is close, I have it at 70. Middleburg is, I guess, 72 degrees for their meridian passing. But then it's the same 281 degrees for the moon set. So if you take a look at this, you can see that the moon would be coming in at an angle like this for Middleburg, then coming out not true west, but just a little bit north of west. And then when you get to Austin, the moon would be coming in 77 degrees and then coming out at 281 degrees, which is north of west. You see the problem? You can plot this out on a line of latitude all the way around, and you're going to see these funky angles, and the moon doesn't zigzag. All right, now let's take a look at the time of how long the moon is around for each one of us. So I'm back at timeanddate.com. This is for Austin, Texas, and I want to remind you right now that the distance that I can see to the horizon around me is 3 miles. You know, the topography around me doesn't vary by but more than 50 feet. It's very, very flat out here. It's central Texas, but we're east of Austin, so this is flat land all the way out to the coast. Okay? So I can see 3 miles in all directions around me, you know, if trees aren't in the way. And if you look at yesterday, the 12th, the moon was visible for exactly 12 hours. For a person in Austin, they can see 3 miles to the east and 3 miles to the west, a 6-mile diameter, can see the moon for 12 hours in Austin, Texas. Now look at today. The moon comes up at 5:19, sets at 5:41. That means the moon is visible to me in just that 6-mile diameter area for 12 hours and 22 minutes. Okay, just let that sink in. What's the next day? From 6:10, so this is 12 hours and 40 minutes that the moon is visible in a 6-mile diameter area. Middleburg, it's the same thing. I mean, it's a little bit different. This is 2 minutes short of being 12 hours yesterday. And now it's 12 hours and 20 minutes. Okay? Still, just a 6-mile diameter area. Let's go back to SketchUp here real quick. For a person standing here in Middleburg, the moon rises here, sets here. It took 12 hours and 20 minutes. Do you see the problem? It's visible to this person here. The horizon is 3 miles away from them. Okay. For one, these angles show that the sun and moon are not doing circles. Number two, the length of time that we're seeing the moon, the sun, that's showing that it's not traveling around this. Okay. And then there's another thing I want you to look at. This right here will help. I noticed it the other day, and it helps support what I'm talking about. So let's take a look at this quick. So as a flat earther, how many times have you seen some sort of image like this? You know, the perspective matrix, how the horizon, everything goes to a vanishing point, You know, this is supposedly the sunrise. It's going to come up to your solar noon and then go off to the horizon. Or if it's the moon, it's going to come up here to the meridian passing and go off to the horizon. Now, I'm just going to play this. I don't need any audio, but it shows this motion, and that's supposedly what we're seeing. That motion right there, look at it. This line is going to be a straight line coming. So if it's the sun or the moon and they're traveling above us, say 3,000 miles, that's what I've heard the most. If this is 3,000 miles high and it's coming up like this, it's going to be following this straight line like this. It's going to get to the solar noon or the meridian passing, and then it's going to shift and it's going to follow down like this. Now what I'm going to show you is when I film it, I've got the P900 on a tripod, and when I have the sun or moon in the frame and I'm zoomed in and I'm not touching it, I just let it sit right there, you can see the direction that the sun or moon is traveling through the frame. Now if this was true, if perspective is the reason, what we would be seeing is this constant gradual rising, but what I would have to be doing is constantly moving, panning the camera along sideways as it's going like this. That's not what I see when I film. What I see when I film is the sun rises and it comes across like this. Okay, so it comes up and then it sort of levels out and then it comes back down. What it looks like when I'm filming is this. If I'm located right here, I see the angle of the moon or sunrise and it ascends. And as it comes up through this area right here, this is where you're going to see it pass through clouds, and you're going to see clouds behind it, and you're going to see birds behind it, right in this range right here. Now, once it gets up a little bit higher, it gets too bright, and I can't film it anymore. And plus, it's going to be too high. It's going to be above the clouds. So you're not going to catch that anymore. It's going to be above the birds. So from, this point here all the way around to this point here, you're not going to catch any of that awesome stuff. It's going to be in this range from the time it rises to the time it's above the clouds. You're going to catch that kind of stuff. But you're going to see it ascends. It's going to follow this, gradual arc because of the solar noon declination or the angle of the meridian passing for the moon. It's going to follow this, and then at this crest, at the peak right here, you're going to see that the moon or the sun, it's no longer ascending. It's now it's just traveling across very gradually, and then here's how you can figure out your meridian if you're filming the moon. Just when you see the moon is sort of it's not ascending fast anymore, and it's almost traveling horizontal, and then it starts going back down. Just whatever time, pick a time like right here when you're filming it and a time right here when you're filming it, and divide it, and right there at that crest, that's the meridian passing. And then it's going to come back down, it's going to follow that arc, and then the last little bit that you film it, it's going to be descending. You're just, when you have, let's say you have the moon in frame while you're recording it, right in this area right here, you're just going to see it zoom down through the frame. You're going to have to move it a little bit, panning wise, but the majority of its travel is going to be descent, and you're going to see that. This is really important. We have the supermoon, which is a rare occurrence. I'm trying to get this video out and up so that you can see this tomorrow so that you can go out and test it yourself. So I recorded the moonrise tonight, and there's a bank of clouds off at the horizon that kept me from seeing the moon come up right at the horizon. This is where it started to show up for me. And it's a little bit hazy. So this isn't the most beautiful, picturesque footage of the moon, but that's really not the purpose of this footage. The purpose of this footage is to study the motion of the moon through the frame. So what I do is I keep moving the camera, uh, getting the moon back in frame, but then I let go. And what I've done is I've trimmed out the areas where I'm readjusting it because it's just bouncing around and it's all crazy shaky to watch. I've taken this footage and sped it up 8x speed, so you don't have to sit here forever to watch it. But this way you get to see quickly the motion of the moon through the frame. Now remember that SketchUp model and the way in that model, the path that it should be following, and then compare it to that perspective matrix where if the moon was coming in from a vanishing point in the horizon to directly overhead, what that angle looks like. And so this is the first 15 minutes of the moonrise here, and then we're going to look at 45 minutes of the moon passing the meridian, but sped up. All right, so what this is 45 minutes of footage right near the meridian passing of the moon. Like I said, even though timeanddate.com says it doesn't happen, it definitely does. Um, so the first half an hour of that 45 minutes is the moon still ascending. And then the last 15 minutes is, it's peaked out and it starts to descend. Now I've got this footage running at 8 times speed, and I've cut out the repositioning of the camera. So what you're going to find is right around the 21-minute mark on this video is going to be about the meridian passing. You'll see that it's traveling level. You'll see that for minutes before and minutes after, it appears to be traveling nearly horizontal. It's just moving through the frame sideways. So check out the rate of ascension right now, and how it slows, and how it crests, and then how it slowly starts descending again. That's really key, that path, because it is not the same path as the perspective matrix. In the perspective matrix, the moon would be rising to a point directly at the meridian passing and descending immediately. It would be going up and then down. And that's not what we see. So a study of this footage will show you that the way I'm modeling it up in SketchUp is really the true path of the moon. Now this is something you can record. You don't need the solar filter like if you're trying to record the sun. You can do this with a regular camera. You could probably do it with your smartphone. All you need to do is to have it on something stable. A tripod would be ideal. This is a study you can do. We have the supermoon tonight. Do it tonight. Tomorrow it's still going to be super big. So if you're not ready to film it tonight, do it tomorrow. The key is studying the path. And then in our modeling, comparing the two and trying to come up with the most accurate modeling possible. So I want your input. I want to refine the model that I'm building to be, as near exact as possible. I'm not saying that it's perfect right now, but it's a starting point. You should see in the footage right now that this is nearly a horizontal path. In just a little bit, you'll see that it starts descending again. Right around here, it's descending now. I only did 15 minutes of footage after the meridian passing. This is going to be the shorter part. But I'd love to see all of your footage. It's by observing, by studying, by going out and doing this, testing, experimenting. Not just watching other people's videos. I'm happy to do this and point things out to look for, but you really got to go do it yourself. This is one that you can do. Now I've sped up this footage in order to make this video short enough that I can get it up today. Well, hopefully, I want to be able to catch footage tonight. The skies are a little cloudy. We'll see what happens. What I'd like to do is put up footage that just runs in real time without being sped up, because then I can put up the time and date stamp, and you can compare the minutes as they tick by and the motion of the moon. Now, when it's fast forwarding like this, I can't do that. So I plan on getting that up soon too for more study.